Hello everyone, and welcome back to another CIV 398 assignment guide. So in this assignment guide, we're going to be going over question 3 of assignment 2, trying to finish our conquest of this beefy assignment. And even though I know questions 1 and 2 were pretty beefy, this one's pretty quick. And you can believe me that it's quick because I got pizza rolls in the oven and I'm not going to let them burn. So let's go through this and hopefully it'll make sense to you guys. Again, very simple question. So the question itself says, for two matrices shown below, determine the values of M1 and M2 such that each matrix, oh I gotta fix that, each matrix is not invertible. Then find the kernel of each matrix. So if we look at these two matrices, we got a 3 by 3 and a 4 by 4, and we see that each one of them has an unknown M, and in matrix A it's M1, and in matrix B it's M2. And the key here is that they're not invertible. So if we remember, a matrix M is not invertible if the determinant of that matrix, so the determinant det of M, is equal to 0. So in order to solve these questions, all we have to do is find the determinants in terms of M1 and M2, and then just solve the equation. One equation, one unknown. So for example, if we were to do this by hand for the first 3 by 3 matrix, we could say, okay, well, the matrix is equal to this, and the determinant is equal to that. And if we expand out the determinant, we get this big long equation. And yes, it looks really gross, but we see that we have one unknown, which is M1, and the other side of it's equal to 0. So we have one equation with one unknown. So all we have to do is actually just solve this equation. Very easy. However, we can use Mathematica. So the key here is to use Mathematica. I know that you guys can do the 3 by 3 no problem. Easy to do. And even when it comes to the 4 by 4, it is doable. You guys can do the 4 by 4, but let's be honest, who wants to do a 4 by 4? No one. So let's recall that we can use a solve function in Mathematica. So the keys of the solve function are this. So the function is solve, and inside that function, inside the square brackets, we got two squiggle brackets. In the first squiggle brackets, we input our equations and what they're equal to. And in the second ones, we input our unknowns. So in this case, it's very simple because we have one equation, and thus the determinant of our matrix M is equal to 0. So remember in Mathematica, if I'm doing a logical equal, I have to go equal equal. I can't just put one equal sign, or else I'm trying to define that as its own variable, and I don't want to do that. And our unknown in this case would just be M1. So all I have to do is define the matrix and then use the solve command, and I can find M1. And very similarly, I can do the same for M2. So the last thing the question wants is just to find the kernel. And if the matrix is not invertible, remember that each matrix that's not invertible will have a kernel. So again, we have two options. One is by hand, so we need to find a vector v that maps to the 0 vector. So if we go to the 3 by 3 case and we expand everything out, well, we got a1, a2, a3, b1, b2, b3, and c1, c2, c3 multiplied by that matrix v is all equal to 0. So again, we know that whole matrix M now. The only unknowns would be v1, v2, and v3. So we can solve for them because we'll have 3 equations and 3 unknowns. But just like before, you guys will see is there's going to be infinite solutions. So what we do, or what I do, is we assume v3 is equal to 1. So you guys can assume v3 is equal to anything you want and then solve for v1 and v2. But me personally, I always just go v3 is equal to 1, and then I solve for v1 and v2, and that'll give me the kernel. But since we're doing everything in Mathematica anyways, and we defined our matrix, all we have to do is just find the null space of M. So type in the function null space, which is the Mathematica equivalent to a kernel, and we want it for our matrix M. And once we press Shift Enter, it'll return us our values. So that's question 3. It's as simple as that. Again, I wasn't overhyping it when I said it was a nice, easy question. During the seminars, I'll go through the Mathematica code to try and clear up any questions about that. But yeah, that's it, guys. And I guess the only challenge in this question, if you guys want, of course, is solving the determinants of the 4 by 4 matrix. You guys would be crazy if you do it, but you never know. Some of you guys just like the punishment, I guess. All right. Thank you guys so much for listening. I will see you guys in question number 4.